So good afternoon or good morning, depending on where you are. I'm obviously Nikhita and one of the co-founders of Artificial. So I thought I could use the time today to talk about this idea of the infamous closed loop lab. With all the advances in AI, I think this has become a pertinent topic. And as we go and talk to many of our customers, I've heard everything from a ton of excitement to worry to how do I actually get this to be a reality. So I thought we could use the time today to kind of dig into that as a problem. So if you looked around in the last week or so, Nature had published a news article about Google AI and DeepMind really building this closed loop lab for material discovery. And so they were able to create an algorithm that tries to figure out what materials to try that are stable substances, and then have a robot actually be responsible for testing them, doing all sorts of experiments. And in the end, what they found was that that entire closed loop system could generate over 400,000 stable substances in a way that humans couldn't in the lab in the same amount of time. And so the reason this is really powerful, there's sort of a quote from the article that's like, this is like ChatGPT for material discovery, is that we can now capture data at an unprecedented rate. We can have AI help us actually go through all of it and figure out new discoveries paired with scientist intuition. And we can do all of that experimentation at a scale that we couldn't even imagine without having to have as much human intervention. So it's a beautiful reality and a beautiful vision to live in a world where scientists can come up with new ideas and then automatically use robots and AI to actually test them and validate them and help them come up with new sort of drugs and therapies. But the reality when we go and talk to a lot of the labs that are contending with this challenge is that a lot of labs still have a workflow where a scientist wants to run an experiment and they still have to cobble together all of these different tools to get to what is ultimately incomplete and untraceable data on the other side. The challenge is really that having all these different tools that have to be put together, like a LIMS system, a bunch of CSVs or Excel spreadsheets, paper SOPs and USBs, and then you have things like device schedulers and all the instrument software, is that you end up with a ton of data silos, which make it really hard to create this vision of the closed loop lab that we were talking about. And so when I talk to customers, the reality that they're really trying to contend with is the fact that they have their lab today. They want to get to this vision of AI driven closed loop labs that can do all their experimentation. And there's a massive gulf between what's true today and what they're trying to get to. The two quotes up there are something I've heard in the last few weeks from our customers, where everyone wants these tools for scientists to be able to design experiments on the fly and run them quickly on this automation. And then the second quote of how do you query your data today? And the answer being, I walked down the hall and I asked 3 people. And so I thought I would spend the first part of this talk to really dig into like, what are the preconditions of creating a closed loop lab and kind of the steps involved from what we've learned in the field from the last 5 years. So the first part of actually putting together a closed loop lab, I kind of think about this like something my advisor told me in grad school, which is that robots and automation is a team sport. And I think building a closed loop lab is even more complex because you have this entire biological component or chemistry component to it. And so really, you need to staff up a team that has scientists who know which hypotheses they want to try, that has automation engineers and software engineers who know how to wrangle all the machines into doing the tasks that we want. You need operators and lab techs to actually help run and maintain all of those machines in that closed loop system. And I think, you know, a lot of people sort of say like, well, if we have a closed loop lab, then why do we need humans? But at the boundary of every automated system, there is a human interaction. And we need people to be able to guide what those systems do. We need them to be able to set them up and get them ready for a run and actually manage the way those systems run the experiments that we want. And so having operators and lab techs becomes increasingly important to managing that entire process. And then finally, you really need someone who has the computational biology and AI background to help build out the algorithms that will actually run on that system. So now that you have your team together, the second part of this process is really putting together the digital infrastructure. And so I think of this like creating the brain in a jar that knows exactly what experiments to run and what you need to do. And so a lot of the companies we work with start off by trying to find a LIMS system or an ELN to help with actually like iterating on that experimentation. They may have some DOE tools. And then very importantly, you need to be able to build an AI algorithm that is capable of taking all the data that it's given and figure out what next set of experiments to actually drive. Another big piece that becomes the sticking point is really this need for open and standard APIs to connect everything in the lab. And so if you think about these boxes that I drew on the right, these would all just be data silos unless there's open APIs to connect everything in a way that you can actually create a closed loop system. And I find that a lot of companies get hung up on that point because a lot of the tools are not mature enough to be able to be connected in that way. The third piece folks need is really a digital twin to help simulate everything that's happening. And so this could be like a 3D digital twin, but very importantly, a digital twin for the entire workflow process, so that you can actually create a new workflow and then test it and see what it would look like and simulate it before you send it to the robot to run for hours and hours and hours to give you the output that you're looking for. And at the end of all of it, you really need a central place to put all the data that you've captured, so that you can actually leverage it to figure out the next set of experiments to run. Now that you have sort of the brain in the jar, you need the actual system that will do the hard work and actually run everything. So this is one of the most like complex things to wrangle because we have so many different instruments, we have different schedulers, they all need to be connected, and you need to be able to remotely manage them and test them when they're actually running in real life. And so the first thing people do is they go spend a bunch of their CapEx budget and buy a bunch of instruments and robots to put into lab. And then it creates this sudden problem of the fact that like we need people to actually help manage that system, be able to maintain it, fix it if it's an error. So you need to build out these tools for actual SOPs and for monitoring and helping people kind of know how to navigate this complicated system. The third part that you really need is digital workflow automation tools. And so what I mean by that is essentially ways for you to stitch together the process that you want to run as an experiment. So I would need a tool for a scientist to be able to say, I want to run an ELISA, here's the parameters, and then I want to test this with all these different conditions and get the data on the other side. And then finally, as these systems like the Google Mind system, DeepMind system are running, we need the ability to connect into that instrument or that system and know exactly what's happening and be able to debug it and manage it remotely as it's doing the actual experimentation. So if you've done all this correctly, you end up with a stack that looks something like this. That's often kind of stitched together with glue code that automation and software engineers have written in the lab. And so you have kind of the biodesign tools and ELN at the top, the devices at the bottom, and then all these different layers that are designed to make those two actually work together. Once that stack kind of comes together, the next step that a lot of companies go through is like, okay, I need to be able to give my scientists a way to create new workflows to run and test in the real world. So this is an example of a really simple workflow, but these can get really complex with all the different parameters and things that people want to test, but you need somewhere that you can describe and manage and version all of these workflows within your entire digital system. And so this is an example where a scientist generates a new set of hypotheses and combines that with hypotheses that an AI system may have created. We need the ability to connect that to what an operator needs to do or a lab tech needs to do to actually get that system ready for a run. We then need the ability to connect an adapter to the system that we have and actually kick off those runs and have the robots do what we need them to do. And then we need a way to guide that operator through actual cleanup and setting up for the next set of experiments. And then finally, we need a step to take all the data that was generated as part of that experiment and then put it back into the algorithm to figure out the next set of experiments to run. And so in a lab, you can have tens or hundreds of these workflows, but there has to be a tool where you can actually describe and iterate and plan all of these experiments. Once you put that workflow together and you're ready to run it, you need to be able to test whether it'll work in the way that you imagine. So this is a picture of a system, and then we put a digital twin on the other side that's actually showing what that workflow running might look like, and what might cause an error, when it might need manual intervention. So you need ways to be able to test and simulate exactly what your workflows will do if they're actually set up to run on these complicated systems. So this is where tools like digital twins can be really powerful, because they allow you to very quickly iterate and see what will happen, and then make the changes you need in the workflow that you've designed. And then the final step of making that closed loop lab a reality is really taking all of that and making it accessible through the cloud, so that you could be sitting anywhere in the world, but you can actually check in on that system, know if it's running exactly as it should, and then if there's an error, be able to go and give it the attention it needs, or have someone in the lab do that, so that the process can run smoothly. So this is really important, because a lot of the closed loop systems will run for hours or days or even weeks at a time. And so to be able to help intervene whenever things go wrong, it's super critical to be able to know and be alerted of it from a remote perspective. I think one of the things that people underestimate is the amount of time that robots do exactly what they're expected to do. And oftentimes robots mess up, they'll break things. And so having more and more tools to be alerted of that and being able to fix it really quickly becomes really important in order to get the most out of the spend on that entire system. And so hopefully that entire set of steps helped you understand the complexity and ways in which a closed loop lab has to get built. I thought the second part of the talk could really focus on the parts of this that Artificial has been focused on building, and ways in which we can help with that process. And so I wanted to start by kind of sharing our original premise as a company. And so our goal, if you remember the first slide I showed you with like the scientists wanting to run an experiment, is really to make that process as easy and simple as possible. And so here, what Artificial does is it brings together all the AI algorithms, the data and the LIMS that you might have in your lab, all the SOPs that you need people to be guided through, and then all the lab instruments into a single cloud platform, so you can actually connect everything and have it work together. What this looks like from a stack perspective is, if you saw the steps of building out the digital and the physical stack, we really focus on taking requests from a scientist in a DOE tool or a LIMS. So taking all the requests for new experiments to run, and then having the entire digital workflow to actually orchestrate everything in the real world, including people, the machines, and all the data, so that you can get the results on the other side and then figure out the next hypothesis to test. So we really focus on building out all the stack layers here, so that you can use our tools to be able to build out that vision of the closed loop lab within your entire company. What this looks like from design, optimize, run, learn loop is really something like this, where a scientist can come in and use our tools to design a new experiment that they want to run. They can then use our scheduling tools to actually optimize how that experiment runs on the systems. So they can batch things together, figure out the right way to cluster these experiments together to get the most value and throughput. And then they can use our adapters in order to actually run the robotics and the instruments in the real world. So we have connectivity to all the different systems and liquid handlers, and we'll actually trigger those runs to happen. And then we capture all of the data off of those instruments so that you can learn and figure out the next set of experiments to run using your AI. And so we've really focused on being the digital foundation on which you can go from design to optimize to run, and then learning with an AI algorithm in place. What this looks like from a product perspective is we essentially have two core components to our platform. The first is what we call Artificial Lab Ops, and that's really the kind of central command center where anyone can go to run new requests, monitor exactly what's happening on their closed loop system, and be able to actually manage the schedule and change it if required to get the most out of the throughput of their particular lab. The second part of the platform is really the Artificial Digital Lab Toolbox. So you can think of this like a set of tools that are no code and low code for automation engineers and scientists to be able to build out the closed loop platform within their lab themselves. And so one of the things that we heard a lot from our customers is that people want to be able to keep the control of building these things in-house because science is always changing. And so the artificial digital lab toolbox is really designed to give you that flexibility so that you can make those changes yourself and leverage our tools to make that vision a reality. Now, digging into each of these steps a little bit, so the design process looks a little bit like this, where you can go in and start to create the experiment that you want to run. We have ways for you to manage all the materials and consumables that need to go into that system. And then in natural language, I can actually go and describe the various steps that I need to take. This could include manual steps, so me guiding a lab tech through setting up a system or managing it and recording things like lot numbers. It can also include automated steps, like kicking off a run on a Tcan or a Hamilton or a high-res system. And it can also include data steps, like putting all that data into a data lake or AWS or Azure or whatever, so that you can do downstream analytics. And then finally, you can also connect your AI algorithms so that you can have that create the new set of experiments to run. So it's a really simple way to kind of create these drafts of experiments before you actually send them to run on a system. The next step in the process is really to optimize the schedule. And so here we have a series of tools that let you actually manage the schedule with which these experiments will run on all the different instruments. And so if you have a closed loop system, this is where you could go in and see what the plan is for when these experiments will run, move them around. And then we have an orchestration engine that actually helps you figure out the best time to run it in order to get the greatest throughput over time. In other lab contexts, like cell culture or even simple kind of 3 liquid handler setups, our customers also use these tools to help them optimize how those experiments run on the various systems. So it can be really helpful for like batching and then figuring out like how your cell culture job might need to run in a few weeks and things like that. The next step in the process is to actually execute that experiment. So we have a series of tools for operators and lab techs to be guided through actually setting up that experiment on a particular system. And so instead of having to learn all the different software for a particular like instrument, we have a single pane of glass where you can go in and walk through the checklist of everything that needs to happen. And so this is where you can record things like lot numbers, watch a video of exactly what's required. And this really helps operators get trained up faster and then deal with things like errors and maintenance as those come up without having to go through like a paper binder of SOPs to manage these complex labs. And then for the actual automation, we have a series of tools to help monitor and actually manage all the work that's happening. So in this case, you see a bunch of different experiments running, like a bunch of DNA isolation and NGS jobs. You can track the progress of any of those experiments and what data might be coming off. We also show things like the logs and errors in case there's something that you need to take attention on. And then we let you monitor the state of that whole system so you know at any given point which instruments are running and which ones might need some attention. So this is really valuable for that remote visibility and giving you the tools to manage and schedule all the systems in a lab. And then the final part of the process is really bringing all of that data together. And so here, we essentially give scientists a complete data record with a view of exactly what happened as part of that experiment. So I might be connected to things like benchling or Solario, and we'll show you exactly what warnings or errors might have happened in that process. We also show you all the manual steps. So when an operator loaded things into the system, how long it was before a buffer was added and things like that, as well as operator notes. And then we pull all the results off the instruments and consolidate them so they can be used for downstream AI or analytics of any sort. So hopefully that helped you kind of see how we think about the vision of the closed loop lab and use the artificial platform to give labs the ability to kind of drive towards that reality. Really for customers, they see the value in like a single intuitive command center that helps them connect everything from the hardware, the software, the informatics, and an AI, regardless of what vendor they're using. We also provide tools for global and remote visibility. And so I have lots of scientists who love the fact that they can be away from the lab and still check in on exactly what's happening. And so the walk away time gets majorly enhanced. And then we also help by creating higher throughput, because you can simulate the process, figure out the optimal schedule and batching before you ever run anything. And then finally, we help bring all that together by reducing the amount of human errors and enabling labs to get to results and data much faster. So I wanted to kind of, near the end of the talk, share a case study that we've done with a large pharma that really talks about this exact case of the closed loop lab. And they had come to us with this challenge that they wanted to close the design, build, test, learn loop. But in the current state, they had scientists sitting in a room and figuring out which experiments to run every month and putting them in a spreadsheet. They had lab techs that were doing these manual SOPs to actually run all those experiments in the lab. And then finally, if you ask them, how do you query your data today? The answer was, I walked down the hall and I asked 3 people. And so what we did with them as Artificial is really connect all of that together. And so they have their own proprietary AI algorithm to figure out the next set of experiments to try. We take those set of experiments and then we actually run everything in terms of the robots. We guide the people, we coordinate all the data moving around, and then we put all that data back so that they can figure out the next set of experiments to run with their AI algorithm. So we very much partnered with them to help make this vision a reality. And so hopefully throughout this talk, you got a sense for, the way that we really think about what we're building is to help close that chasm and make the tools and data gulf a little less deep. And so we want to partner with labs to make it easier to get to that closed loop lab reality. And we very much focus on building out the tools so that labs can take that and build it in-house and feel good about having the customization and the management of all of that in the eyes and hands of their automation and engineers and scientists. Really, for us, we worked with labs that are on this automation journey at any step. And so we started with folks who just have a bunch of manual processes. We've also worked with folks who have just a few different liquid handlers and instruments. Maybe they're starting to digitize some of their workflows and SOPs. But really, we're here to partner with you as you go on this automation journey and help you get to that vision of the AI closed loop lab that everyone is kind of hungry for in this space. And so I wanted to end with that. If you'd love to reach out, my email is Nikhita, Nikhita @artificial.com, or happy to hear from anyone, even in how they're thinking about building this closed loop lab reality.